So, in the previous lecture I described how Lorentz transformation can be completely restated in terms of geometrical constructions, and that is because of Minkowski, who developed all this geometrical representation. And the recipe is very simple. If you have frame S, and in that frame S, for that frame S you draw two lines perpendicular to each other, call this as x axis and this as CT axis, and any point on this diagram corresponds to an event which occurs at a certain point on the x axis and at a certain time. So, if this is that representative point P, what do you do? You draw a line parallel to the CT axis and then you reach here, this point, and then draw a line parallel to the x axis like this, and you reach here. This is x, this is x. So, this is the place. Once you get the x, you know, okay, at this point of the x axis the event has occurred. And when did it occur? So, this is CT. So, once you know this CT, then you know that okay, the event occurred at that particular instant. So, you know the location and you know the time. So, the event is described in S frame by this point P. What if I look at this event from frame S prime, which moves with respect to S with a velocity v in positive x direction and so. So, if you are in S prime frame, the same event which has coordinates x and t or x and CT, the corresponding coordinates will be x prime and CT prime. So, what we want to know is, in S prime frame, where did the event occur and when did the event occur, and how do I get this x prime and t prime from x and t? One way is Lorentz transformation, we had been doing that, but now forget Lorentz transformation, come here. The first thing is, once you have the S prime frame, you know the velocity of this frame with respect to S, and therefore, the v velocity v is known. So, calculate this angle theta, tan theta is equal to v by c, and once you get this theta, draw a line, call it x prime line, and this angle is theta, and draw another line with the same angle from this CT axis, and this is that line, this angle is also theta, and this is CT prime, this line is CT prime line. So, now you have oblique axis for S prime, you have oblique axis here, and what you, if you want to know what is x prime, what is t prime, what you do, your axes are now oblique. So, same story, from this point P, from the same point P, you draw a line parallel to this CT axis. So, the line will be like this, the line will be like this. Let us call this point as Q, call this point as Q, and then draw a line parallel to this x prime line. So, from this P you draw a line parallel to this, like this, parallel to this x prime axis, and call this point as, let us say, R. So, this OQ, this you have to measure, and x prime will be equal to OQ. Normally, I will say that okay, these are my axes, so this is x prime and this is CT prime, but on this line, yes, in this diagram, yes, this is x prime and this is CT prime, but actual x prime is this multiplied by square root 1 minus beta square by 1 plus beta square, and CT prime is equal to this OR and multiplied by the same factor 1 minus beta square by 1 plus beta square. And what is beta? This is beta. So, draw these two lines, measure this OQ and multiply that OQ by this factor square root 1 minus beta square 1 plus beta square, beta is V by C. So, you know what is x prime, and similarly measure this OR and then multiply that OR, that length OR, by this square root of 1 minus beta square by 1 plus beta square, and you get CT prime. So, from this geometrical construction you know x prime t prime once you know x and t. So, that is the thing which we discussed. And if you go parallel to x prime line, suppose you have an event here represented by this, and this is parallel. So, you are going parallel to the x prime axis. So, then x prime will change, but this t prime will not change, because from here you have to draw a line parallel to x prime. So, the same line will be there, same line will be there. From here you draw a line parallel to x prime, the same line will be there. So, all these events have same t prime, they are simultaneous in s prime. The events represented by points like this, like this, like this, like this. If you draw this line which is parallel to x prime line, then all points on this line represent events which are simultaneous. Similarly, this point, this point, this point, this point, there is an event corresponding to this, there is an event corresponding to this, there is an event corresponding to this, and so on. For all these events, once you draw a line parallel to CT prime, they will all come to this Q only. So, all these events are occurring at same x prime. In S prime frame, they are occurring at the same point. So, these are the things which we discussed. And another thing you can just see that since our frames always have velocity less than c, so that means this beta is always less than 1, and therefore, this theta is always less than pi by 4 or 45 degrees. So, this is one frame with certain velocity v. If you go to yet another frame with larger speed, larger velocity, larger value of v, what will happen? This theta will increase, and for that frame you will have your x prime line somewhere here, and then equally you have to incline this also by equal angle. So, it is like this. So, this will be CT prime, this will be x prime, they are converging like that. If you increase the speed still higher, your x prime will be, for that new frame, your x prime will be like this and your CT prime will be like this, and so on. But this line, x prime line, will never reach 45 degrees and will never cross 45 degrees, and the CT prime, if you measure from the CT axis clockwise, this also will not reach 45 degrees, because this angle and this angle are same. So, that also you keep in mind. Now, let us derive some things which we derive from Lorentz transformations. Relativity of simultaneity. Two events which are simultaneous in one frame occurring at different points are not simultaneous in other frame. We discussed that. So, if you have two events, say E1, E2, which occur at the same time in S frame, from S prime frame, they are not occurring simultaneously, one precedes the other. So, how do I see here? Suppose I have a S frame represented by this x and this CT, and then S prime frame represented by this x prime and this CT prime. This angle is theta, this angle is theta, tan theta is V by C. And then let us say there are two events. Suppose you have two events and both these events occur at the same time, they are simultaneous in S. So, T is same, x is different, but T is same. So, if one event is represented by this point, another event is represented by a point like this. This is P1 and this is P2. So, in S frame, how do I get t? You just draw a line parallel to x axis, and then it meets here. So, this is the time of event P1. And what is the time of P2? Once again from P2 you draw a line parallel to x axis, it is the same line, it will cut at the same point. So, same t. So, they are simultaneous in S frame. What are their time in S prime frame? For this event, what is t prime? How do I get t prime? To get t prime, I have to draw a line parallel to this x prime axis. So, in S prime, how do I get time for this? Time for this, t prime for this, you have to draw parallel to this from here. So, you draw a line which is parallel to this, and it meets the Ct prime axis here, this length, this is O, and this is let us say some q1. So, OQ1, Ct prime is equal to OQ1 and multiplied by square root 1 minus beta square 1 plus beta square, that is Ct prime, and this is for the first event. For the second event, for this event represented by this point, once again draw a line parallel to x prime axis. So, from here when you draw a line parallel to x prime axis, it goes like this and it meets somewhere here another point O, another point Q2. Both these lines are parallel to x prime axis. So, Ct2 prime will be this OQ2 and multiplied by square root 1 minus beta square by 1 plus beta square. So, since OQ1 is different from OQ2, these events are not simultaneous in S prime, T1 prime is not equal to T2 prime. Events which are simultaneous in one frame, they are not simultaneous in another frame. You can draw events which are simultaneous in S prime in the same diagram. How do I do that? This is x, this is Ct, this is x prime, and this is Ct prime, and then you have points, 2 points, 2 events which are simultaneous in S prime. So, one point is here and another point is here, okay, P1 here and P2 here, and this line P1 P2 is parallel to this x prime axis. So, if you are moving parallel to x prime axis, t prime does not change, just like in our normal xy plane. If you are moving parallel to x axis, your y does not change. Similarly, if you are moving parallel to x prime, your t prime does not change. So, these two events are simultaneous in S prime. So, t prime for this event is same as t prime for this event. What about time in frame S? For this, if you want to find time in frame S, you will just draw a line parallel to this x axis and that will be like this. And for this event, if you want to get time in frame S, then you draw a line which is parallel to this, and you see that this is Ct1 and this is Ct2. So, T1 is not equal to T2. Now, let me go further. Let me say I have 2 events P1 and P2. P1 is here, P1 is represented by this point and P2 is represented by this point, and purposely I have drawn it this way that slope of this P1 P2 is more than 45 degrees. My question is, can I find a frame in which these 2 events are simultaneous? So, in this S frame, definitely no. P1, this is Ct, P2, that is Ct. So, T1 is not equal to T2, they are not simultaneous. But can I find a frame? If I go to any S prime frame, it will be like this: S prime here, X prime, and Ct prime here. And this is not parallel to this line. If you increase the velocity, it will go here and that will go here. Still, this is not parallel to this line, because this slope I have drawn is more than 45 degree, and for no frame you can have this x prime which makes angle with x axis which is more than 45 degrees. So, for no frame, x prime axis can be parallel to P1 P2, and the two events are simultaneously in a frame only if this P1 P2 is parallel to x prime axis, x prime line. Okay. So, in this case I do not have any frame if P1 P2 has slope greater than 1, right, greater than 1. So, this angle is more than 45 degree. There is no frame in which these two events are simultaneous. So, always T1 is not equal to T2 for all frame, not only for S. Okay, let me put prime for any frame. And you can write this condition in terms of x and t. For this, if you draw a line parallel to the CT axis and parallel to this x axis, then this is more than 45 degrees, means this length is more than this length. And how much is this length? This is c times T2 minus T1. And how much is this length? This is x2 minus x1. All right, simple. You draw a line here, this is x1. You draw a line here, this is x2. So, this is x2 minus x1. You draw a line here, this will be CT1. You draw a line here, this will be CT2. So, that is this. And for this condition is c times T2 minus T1 is greater than x2 minus x1. So, if you have two events in any frame, if you find in any one frame, you find that c into T2 minus T1 is greater than x2 minus x1, then those two cannot be simultaneous in any frame. So, there is one result. Such events, pair of events is called time-like. Okay. Is there a frame in which the two events are occurring at the same position? If two events are occurring at the same position, that means this line is parallel to this CT prime line. Okay, because if you are going parallel to CT prime, the CT prime is changing, but x prime is not changing. So, x prime for this will be same if this line is parallel to CT prime, and that is always possible, because if this is greater than 45 degrees, this is less than 45 degrees. And you can always find velocity so that this angle and this angle are same, this is less than 45 degrees. So, you can always find a frame for which this angle is same as this angle, and in that case this line and this line are parallel to each other, and in that frame this point, this event and this event, they are occurring at the same x prime. So, if that is this frame, then it is this x prime. Okay, you extend this line, it is this x prime, this length, multiplied by this factor, of course. So, at that x prime this event is occurring, at that x prime this event is occurring at different time. So, your space coordinate can collapse, time coordinates cannot. So, that is known as timeline. We will go further and derive the time dilation thing. Okay. So, let me erase this, make space and then do that. So, this frame that we have drawn here, x prime frame, S prime, and this P1, P2 is parallel to the CT prime line. So, that in this frame the two events are occurring at the same position, and therefore, the time interval between these two events as measured in this frame S prime is the proper time interval between these two events. Okay, remember that. So, proper time interval between the two events is the time interval measured in this S prime frame where the two are occurring at the same position. And what is that? What is that time interval? For this point, what is the time t prime for this event? For that you have to draw a line parallel to x prime axis or x prime line, and then this will meet somewhere here, it will meet CT prime axis somewhere here, and this gives you t prime of this. Similarly, to get t prime of this, from here you will draw a line parallel to x prime axis, and that will be like this, and that will meet here, and this will give you CT prime for this event. This gives you CT prime for this event, and therefore, this interval, this distance, this separation gives you the time interval CT2 prime minus CT1 prime. But remember, don't forget to multiply it by that scale factor. So, actual this is on this diagram. On this diagram, you have C2 prime minus CT1 prime is equal to, this is C2 prime, this is CT1 prime, and this is that difference, which is same as P1, P2. This is a parallelogram. This is a parallelogram. P1, P2 is parallel to this is parallel to that. So, this separation is same as P1, P2. So, it is P1, P2. But that is on the this Minkowski diagram, and if you want the time in seconds, this has to be multiplied by 1 minus beta square by 1 plus beta square. So, that is the time interval. So, T2 prime minus T1 prime is equal to P1 P2 divided by C, and then 1 minus beta square 1 plus beta square here, square root there. That is the proper time interval. And then what is the time interval in frame S? In frame S, this is x, this is CT. So, what is the time in frame S for this event? You draw a line parallel to x axis, and then you get a point somewhere here. This is your time for this event as measured in S frame. I am going parallel to x axis, this x axis. So, I am getting this. This is my CT1, this is my CT1, right, this is CT1. And similarly, for P2 you draw a line which is parallel to x axis, and then you reach here, and this is your CT2. This is CT1, this is CT2, and this difference is CT2 minus CT1, and no scale factor, no square root 1 minus beta square. This is S frame, and this length is same as this length here. This length is same as this length here. This is CT2 minus CT1. So, C times T2 and minus C times T1 is equal to this length here, and this length is P1 P2 into cos theta. This angle is theta. Okay, this angle is theta. This angle is theta. This is theta here. This is theta here, and it is the same angle. This line is parallel to this line. This line is parallel to this line. So you have that same theta here, and it is cos theta. P1 P2 into cos theta. So it is P1 P2 into cos theta. So T2 minus T1, remember this improper time interval. This is improper time interval. Is equal to P1 P2 by C, and then cos theta, and cos theta is 1 by square root of 1 plus beta square. We have done it several times. Tan theta is beta, and therefore cos theta is 1 by square root 1 plus beta square. So if you write this as delta t improper, and if you write this as delta t proper, what you get is delta t proper is equal to, or let me divide it. This is P1 P2 C, P1 P2 C, and this lower part. Okay, this part P1 P2 by C, and then divided by square root of 1 plus beta square. That is here. That is T2 minus T1. For this I can write T2 minus T1. So it is delta t, T2 minus T1 is delta t improper, and then multiplied by this factor square root of 1 minus beta square. That means delta t improper and multiplied by square root of 1 minus b square by c square. Proper time interval is the smallest time interval between two events in measured across all frames, and that factor by which it is smaller is square root 1 minus b square by c square. That is the time dilation formula we derived from Lorentz transformation. So the same equation you can get using all the geometrical representations. Similarly, you can derive equation for length contraction, whatever you have done with Lorentz transformation using algebra. T is equal to T prime is equal to T minus x b by c square, etc., etc. Everything you can do with this recipe. So that is the strength of this Minkowski diagram.